Hello everyone, welcome back to another video. Today we're going to be looking at the momentum and impulse questions from the 2024 June KZN examination. As always, if you'd like to attempt the question yourself, pause the video right now. I'll do the answers in 3, 2, 1. All right, let's look at the question. A cannon has a mass of 2,150 kilograms and it fires cannonballs during a routine training exercise. Each cannonball travels at a speed of 70 meters per second to the right. When it leaves the cannon, take the initial velocity of a cannonball before being fired as 0. All right, so they've given us a nice diagram there and they've given us the velocity once it leaves, all well and good. The cannon fires 200 cannonballs per minute. The mass of each cannonball is 30 grams. Okay, 4.1.1 defined in words. Again, definitions, we don't waste our time. You have access to them, so learn them. Calculate the magnitude. So the question here, magnitude, meaning just calculate the value. We don't want the sign, we don't need the direction, etc. So they want to know what is the momentum of each cannonball when it leaves the gun. So the momentum of each cannonball. So they want to know when one cannonball leaves, what momentum does it leave with? All right. So question 4.1.2, we know that momentum is equal to the mass times the velocity. Right? The mass of a cannonball is 70 grams. We need to convert that to kilograms. So 70 divided by 1,000 and then multiplied by the velocity. Sorry, the mass is not 70, the mass is 30. So 30 grams and the velocity is 70. And that leaves us with an answer of 2,1 kilograms meters per second. We don't need to put a direction, they just wanted the magnitude. Okay, I think that's fine. Question 4.1.3, calculate the net average force that each cannonball exerts on the cannon. Okay, so we know when we're dealing with the section 4.1.3, when you talk about force, more often than not, we're going to use F net times delta T equals delta P. Right? Now, we can work out delta P, that's not a problem. But it's the time that we're not sure about. Okay? So let's just consider, or let's think about what information did they give us. Maybe we can extract some information from there to help us with the time. So it has to do with this sentence right here. The cannon fires 200 cannonballs per minute. Right? Now, watch how we can do this. So 200 cannonballs in 60 seconds. Right? So if you convert that, that is 3,33 cannonballs in 1 second. Right? This is actually frequency. But we're not interested in the frequency. We want to know how many seconds per cannonball. Right? So there's quite a big difference here. We need to understand what the difference is. Right now we have 3,33 cannonballs being shot every second. But we want to know in 1 second how many leave. Right? We want to know how many seconds per cannonball. How many seconds per cannonball? So to do that, we invert it. So we will say, if we have frequency and we want period, so period is equal to 1 over frequency and frequency equals 1 over period. That means 1 over 3,33, and that's going to give me an answer of 0,3. So this is 0,3 seconds per cannonball. This is our contact time. So we'll say Fnet multiplied by 0,3 equals, now remember to calculate delta P, that's going to be the mass, so 30 over 1,000, and then the final velocity is 70, and it's stationary at the start, so 70 minus 0. So now we can solve for Fnet. And you solve for Fnet, you're going to get Fnet equals 7 newtons. Again, you're not interested in the direction, they just want the magnitude. Okay? Let's move on. Question 4.2. Trolley X of mass 20 kilograms moving at speed v collides with a stationary trolley Y of mass 10. All right, so let's input that information. So we know the v here is 0, right? The trolleys stick together on impact. After the collision, the combined velocity is 5 to the right. State the principle. Again, we're not interested in that right now. We want to calculate the next one, which is calculate the speed of trolley X before the collision. So this one, you'll see, remember you have 3 different types of collisions. This one is where you have 2 objects joining together, so their masses will join. So in this case, you're going to have m1v1 plus m2v2 equals, and that's going to be m1 plus m2 times v. And again, I'm adding them because after the collision, they've stuck together. So the mass is 20 and the velocity is v, we don't know what it is, plus the mass is 10 and the velocity is 0, it's stationary, and that's equal to 20 plus 10 multiplied by 5. And now our only unknown is v, so we can solve for v, and when we solve for v, we get v is equal to 7.5 meters per second. That's it. Okay, so that's it for this video. If you liked the video, if you enjoyed it, please consider leaving a like and subscribing. If there's something that you wanted to ask, you can ask it in the comments, or if you have a suggestion for the next video, leave it in the comment section below. Until the next one, bye bye.